Okay, this is a review of supplemental problem number 82. We have two blocks, an 800 gram and a 400 gram block. The system is released from rest, but take note that the pulley is light and frictionless, so it will not affect the problem, and the string itself will be considered of negligible mass. It says massless string, okay? Now, just considering what would happen here if actually the friction between the table and the block is negligible, there's no friction on the table, the 400 gram block should accelerate downward at the same rate that the 800 gram block accelerates to the right. Let's draw the free body diagram for each of these objects per what part A says to do. So let's label this block A and this block B. This will have MAG. It'll have an equal normal force up and a tension force to the right. This block will have a weight downward and a tension force upward, and know that the block on the table will accelerate to the right while the block on the right hand side will accelerate downward since the net force is downward. And being good physics students, what we should do is make sure we have an axis in place for each of our free body diagrams. Now, going on to part B. Use Newton's second law to write an equation for the 800 gram mass. So in part B, we write sigma F equals MA. Now it didn't say in the X or Y, but clearly the most interesting thing going on for this problem is in the X-axis, because that's the direction of the acceleration. So if I write this for the X-axis exclusively, then we know the only force acting on it is the tension, and the tension is to the right in the positive direction. So that means tension, being the only force, is positive. That's what sigma F does. We add up all the forces. Now, the acceleration is also in the positive direction, so we'll label this MA times a positive acceleration. For part C, we're going to go through a similar operation for the second block, block B. We're going to do sigma F in the Y direction, since that's the only direction of motion for that block. And we know that it's the same acceleration as for block B, so we'll use the letter A, and this will be MB on the right-hand side, forgive me. Now, for the sum of the forces, what will go in there is that we have MBG down and tension up. I'm going to say that down is positive since that's the direction of acceleration, which keeps this as positive. And then we'll have MBG as positive, tension as negative. That accomplishes parts A, B, and C at this point. Part D says, find the acceleration of the system by simultaneously solving the system of two equations. This is very specific that it wants to use a system of equations. So in this case, we can solve by substituting this into here. So let's do that down here. MBG minus MAA equals MBA. Get all the A's on one side by adding MA times the acceleration to each side. And now, if we factor out the acceleration on the right, we have this. So if we want acceleration, we can divide the left side by MA plus MB, and now we can substitute our values in. Of course, be careful, when we are doing work in physics, we always convert from grams to kilograms, so let's do that right now. Okay, we're going to have, for the answer here, we're going to calculate it using 0.4 kilograms times 10 meters per second squared all over 0.8 kilograms plus 0.4 kilograms. And doing that will get us an acceleration of 3.3 meters per second squared. Okay, now the last part of the problem is asking us to find the tension. We can simply substitute what we have for the acceleration back into either equation with the tension. So that means if we go back up, the easiest equation that we could utilize is the one from B, in my opinion. M times A times acceleration. So that means that we have a 0.8 kilogram mass times an acceleration of 3.3 meters per second squared. And to complete this out, we arrive at an answer of 2.6 newtons. And there you have it.